In this video, we are going to learn about regular polygons. A regular polygon is a convex polygon with all sides congruent and all angles also congruent. A polygon is inscribed in a circle and the circle is circumscribed about the polygon, where each vertex of the polygon lies on the circle. The radius of a regular polygon is the distance from the center to a vertex of the polygon. A central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices. The apothem of a regular polygon is the distance from the center to a side. Now I will explain each of these. So let us first of all try to understand what is a convex and a concave polygon. As you can see here, a polygon is a closed figure. So this is figure 1 and this is figure 2. Now both of them are closed. But what about the angles? The angles are less than 180. So a concave polygon will have all its angles less than 180. All its internal angles less than 180. But what about the angles here? This is less than 180, this is less than 180, but this angle is greater than 180. Therefore, this is called concave polygon, whereas the first one, this is called convex polygon. So concave and convex polygons you understood. Now, a regular polygon is a convex polygon with all sides congruent and hence all angles also congruent. So you can see over here, this is a regular polygon with how many sides? 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, and all these angles are less than 180. So this is also a convex polygon. Now, the center is where all the diagonals of the polygon meet. So this is the point O, which is center. A polygon is inscribed in a circle with this point as center, and let us consider OP as radius. If you draw a circle, all these points will lie on the circumference of the circle. That is what is mentioned here. A polygon is inscribed in a circle and the circle is circumscribed about the polygon, where each vertex of the polygon lies on the circle. So if you draw a circle with O as center and OP as radius, and if you draw a circle, all these vertices P, Q, R, these all will lie on the circumference of the circle. Next part is radius. OP, as you already are aware, OP, OQ, OR, these are called radius. Central angle is angle POQ. So POQ, this angle is central angle. Interior angle, these angles are called interior angles. So here you can say PQR, QRS, PQR, QRS, these are all interior angles. And what is apothem? Apothem is apothem is a line joining the midpoint of PQ, the side of this polygon, midpoint with the center O, and this will be this angle OAQ will be perpendicular, that is 90 degree to PQ. So if you drop a perpendicular from O to PQ, it will bisect, that is, it will meet at the midpoint, PA is equal to AQ. So A is the midpoint. Or if you simply join A and O, it will be 90 degree. So these were the few terms which I wanted to make you familiar with. Now some theorems on polygon. Theorems: angles and areas of polygon. The sum of the measures of interior angles of an n-sided polygon is n minus 2 times 180. This is the first theorem. The measure of each interior angle of a regular n-sided polygon is whatever is the sum divided by n. So n minus 2 times 180 by n. That is the measure of each angle. Don't worry, I am going to explain all these with numeric numbers and examples, so you will understand it better. The sum of the measure of all the exterior angles of any polygon is 360, and the area of a regular polygon is half the product of the apothem A and the perimeter P. That is, A equals to half times A times P. P is the perimeter, A is the apothem, and this is 1 by 2. So that gives you the area of the regular polygon. Now in this figure, as you can see, A, B, C, D, E, F. So that is a regular polygon, and it has 6 sides. So we call it hexagon. So this is a hexagon. G is the midpoint of ED, and if you join midpoint with O, the center of the polygon, then that is called apothem, as already discussed. That is called apothem. Now, sum of all the internal angles. The formula given was n minus 2 times 180, where n is the number of sides. So number of sides of this hexagon is 6. So 6 minus 2 times 180, that is 720, is sum of all these angles. If you measure all these angles individually and add them, your sum will be 720, and they will all be equal. So what is the measure of each angle? Find the sum of the angle and divide it by the number of sides. So sum of the angle is 720, divide it by number of sides, that is 6. So measure of each angle will be 120. Now one more interesting fact is that if you extend this line and extend this line like these, and then measure these angles, the external angles, and sum of these external angles will be 360. Sum of the external angle is 360, and that is for any figure: 6-sided, 7-sided, 9-sided, 12-sided. This is going to be 360 in each case, which is really an interesting fact. So you must remember this. Sum of the external angles of a regular polygon is 360 degrees. So these were few important theorems which has been discussed. Hope you enjoyed the session. If you have any confusion, you can discuss with me in the comment section. You can put your problem in the comment section. Thank you.